I figured that I was going to live my life and go through my career in the U.S. as a volcanologist without ever seeing an eruption within our borders.
One of the things that we'd kicked around is, when will one of these erupt? What's the chances of it erupting?
It began quietly, a low rumble beneath the earth, a pulse that few noticed, but none could stop. In the Pacific Northwest, Mount St. Helens stood in silence, a pristine, snow-capped giant admired for its beauty, unaware that deep inside, pressure was building. For weeks, the warning signs grew, earthquakes rattling its slopes, steam and ash venting from its peak, the north face bulging outward as magma pressed from within. Scientists watched with unease. Locals waited with curiosity. The mountain itself held its breath. Then, on the morning of May 18, 1980, the calm shattered. In a single violent moment, the north flank collapsed in the largest landslide ever recorded. That collapse uncorked the fury beneath. A sideways blast of searing gas, ash, and pumice traveling faster than the speed of sound. Forests were leveled in seconds. Entire valleys were buried beneath mudflows. The sky turned black as ash billowed 15 miles high, drifting for days and circling the globe. The eruption lasted only moments, but its scars on the land, on the people, on the memory of a region would endure for decades. This is the story of a mountain's fury and the deadliest volcanic eruption in United States history. Southwestern Washington, United States. Nestled amongst lush forests and flowing rivers, Mount St. Helens rises with quiet majesty, a mountain of beauty and hidden power. Mount St. Helens belongs to the Cascade Range, a line of volcanic peaks stretching from California to British Columbia. Born of the slow, relentless collision of the Juan de Fuca Plate beneath the North American Plate. For centuries, Native American tribes revered the mountain, calling it the Smoking Mountain. In their stories, it was both sacred and fearsome, a place of power that could inspire awe or strike with fury. European settlers were equally captivated by its striking cone and fertile slopes, drawn to its beauty and the promise of the land. By the early 20th century, Mount St. Helens earned the nickname the Mount Fuji of America. Adventurers, hikers, and campers flocked to its snow-capped peak, while loggers worked its lower slopes. Beneath this serene facade, however, the mountain carried a long history of eruptions. Over the past 40,000 years, it had repeatedly reshaped the land, with the most recent major eruption occurring in the mid-1800s. By the 20th century, its activity had quieted. The mountain appeared tranquil, a familiar presence to those who lived and worked in its shadow. Yet, beneath that calm, a restless force waited. March 20th, 1980, 3:45 a.m. A magnitude 4.2 earthquake shakes the north flank of Mount St. Helens. After 123 years of silence, the mountain stirs.
We received a notification very early on, right after March 20th, when the first earthquake began. And that was the beginning of the most hectic, 10, 12 months of my life, I guess. We watched very closely as the earthquake swarm escalated in March.
March 20th through 25th. Seismographs fill with activity. More than 170 quakes of magnitude 2.6 or greater rattle the volcano. Pressure is building.
And then that was the 26th, the 27th at noon was the first, or about noon was the first pop.
March 27th, 12:36 p.m. A steam-driven blast tears open the summit.
We are directly over Mount St. Helens right now, and there is no question at all that the volcanic activity has begun. You can see smoke and ash pouring from the top of the mountain, especially on the north side of the mountain.
A new crater, 250 feet wide, forms instantly. Ash rises 7,000 feet into the sky. More explosions follow, throwing ash 11,000 feet high. Fine gray fallout drifts as far as Bend, Oregon, and Spokane, Washington.
My first impression of it was one of not quite chaos, but certainly an unmanaged situation where we were just reacting to what the volcano was doing rather than knowing exactly what was going on.
It was just 20 hours a day of questions. Try to explain things to people. Reporters came in swarms.
And there was this big press conference with several TV cameras. The national media were there, and the Forest Service and the USGS people were talking, and I had to give a spiel about what I'd seen, which was essentially nothing.
March 29th. A second crater appears. From it, blue flames flicker, burning gases released from within the mountain. Static charges in the ash cloud unleash bolts of lightning stretching nearly 2 miles. March 30th. 93 separate outbursts are recorded in a single day. April 1st. Scientists detect strong harmonic tremors, a sign of magma moving underground. April 3rd. Governor Dixie Lee Ray declares an emergency as the mountain grows increasingly restless. April 7th. The twin craters merge, now measuring 1,700 by 1,200 feet and plunging 500 feet deep. April into May. Geologists confirm a massive outward bulge in the north face, 1.5 miles wide and growing 6 feet a day.
What was essentially happening at Mount St. Helens, the mountain up into the volcano itself. Magma moved up into the volcano and it began to grow or form what we call a dome or a cryptodome inside the volcano. And that inflating body of magma or molten material actually broke the north side of the volcano and began to cause the north side of the volcano to expand out toward the north.
By mid-May, it juts more than 400 feet outward, a visible sign of magma pushing from within.
By the time I got here, the bulge was obvious, and we were measuring the rate of northward movement of the bulge at about 6 feet a day, and we knew that wasn't so good.
April 30th. Scientists warn the bulge is unstable. If it collapses, it will trigger a catastrophic eruption. That same day, Governor Ray establishes a red zone around the volcano. Trespassers risk fines or jail time.
I guess it was frightening to be on the volcano. We had some pretty strong discussions about whether or not we should be in the volcano, around the volcano, etc., for personal safety reasons. And the other side taking, well, we got to get the sign spots available.
May 7th. A new round of eruptions shakes the summit. The bulge nears its maximum size. By now, more than 10,000 earthquakes have struck beneath the mountain, most concentrated less than 2 miles below the growing bulge. May 16th. Explosions cease. The mountain quiets, giving the illusion that the worst has passed. May 17th. Under pressure, officials allow property owners back inside the restricted zone to retrieve belongings. Many return to their cabins and campsites, unaware that the mountain's silence is only a mask. May 18th, 6 a.m. The mountain shows no signs of change. The bulge on the north flank continues its steady outward push. Ground temperatures remain stable, and nothing suggests an eruption is imminent. At an observation post 6 miles north, volcanologist David Johnston keeps his watch. His instruments record routine activity, the same patterns seen for weeks. To all appearances, the mountain is quiet.
Dave Johnston had been able to make a measurement with using the range master that he had, Coldwater 2, and found that there'd been no change in rate of movement, actually a slight decrease in rate of movement since the last time the measurement had been made some time before.
Because this is such a symmetrical volcano and because the crater is so high, if there's an explosion, it's probable that the debris, the very hot incandescent ash that would come down, could come down all sides. But right now, there's a very great hazard due to the fact that the glacier is breaking up on this side of the volcano, on the north side, and that could produce a very large avalanche hazard.
You don't mind working in the shadow of the mountain, then?
No, not at all. There's nothing to be scared of. More danger from one of them trees falling on the backside than there is mountain exploding.
Since 1929, 83-year-old Harry R. Truman had called the slopes of Mount St. Helens home, running the Spirit Lake Lodge. As the mountain stirred, officials urged evacuation. But to Harry, the volcano was no enemy. It was a companion of more than 50 years.
Oh, I'm like that old captain. By God, I'm going down the ship. I said, if the damn thing takes this mountain, I'm going along with it. I'd rather be dead than to live without it.
When asked by reporters if he would leave, Harry's reply became legendary.
That's my life. Spirit Lake and Mount St. Helens is my life, folks. I've lived there 50 years. It's a part of me. That mountain and that lake is a part of Truman, and I'm a part of it.
(8:32:11 a.m.) A magnitude 5.1 earthquake strikes beneath Mount St. Helens. As the eruption begins, Johnston reports over the radio, "Vancouver, Vancouver, this is it." In seconds, the north face of the mountain collapses in the largest landslide ever recorded. A blast equal to 25 megatons of TNT tears upward and outward, bursting through the trailing landslide.
You had to see it to believe it, to get that total impression.
I had seen a number of the small steam explosions that had been occurring for the 2 months prior to May 18, but I'd never seen anything on this magnitude, and I knew that it was a huge eruption compared to what we'd seen so far.
8:32:30 a.m. The avalanche plunges into Spirit Lake, displacing the water in a towering wave nearly 600 feet high. The surge slams into a nearby ridge, sending a 290-foot avalanche of rock, mud, and uprooted trees crashing back into the valley.
This avalanche came down the North Fork Toutle and just pushed all the trees in the valley out of the valley down at the head of this avalanche. So at the front end of the avalanche was this big giant bushes and shrubs that had been just scraped off the valley floor and were all down at the end of the avalanche.
There were places north of the volcano which was left pristine. There was old growth in there. Just huge, huge trees, and you could walk in there and not hear a sound because of the vegetation that. It was just a gorgeous, wonderful wilderness there. And to know that in your mind, I actually haven't seen it 4 days beforehand, and come back and see it all gone, that was quite a shock. It took me about 2 weeks of flying across the boundary of the blast zone before I stopped having that physical, emotional hit.
Most of the debris races 13 miles down the North Fork of the Toutle River. The valley is buried beneath up to 600 feet of avalanched material, covering 24 square miles in an instant. With the north face gone, the dacite magma beneath is suddenly exposed to low pressure. Gas-charged rock and superheated steam erupt violently, just seconds after the landslide begins.
The landslide basically uncorked this pressurized body of magma and allowed it to explode or expand out towards the north very rapidly. This is what we call the lateral blast. It was a horizontally directed explosion of incredible magnitude.
Rock, ash, and pumice are hurled into the air as pyroclastic flows, clouds of hot gas and debris, surge from the shattered crater. The lateral blast begins at 220 miles per hour, but rapidly accelerates to 670 miles per hour, nearly the speed of sound. At the vent, the fury lasts for 30 seconds. (8:33 to 8:35 a.m.) The blast front tears across the landscape, flattening trees for 230 square miles. Heat, ash, and rock consume the wilderness in seconds.
The directed blast was really the most destructive event that occurred on the morning of May 18. It completely destroyed an area of 230 square miles in the matter of somewhere between 5 and 9 minutes. It essentially killed every living thing within an area of 230 square miles, and it destroyed hundreds of acres of virgin forest, and it was an incredibly spectacular event.
(8:50 a.m.) The eruption melts nearly all of the mountain's glaciers and snow. Water mixes with ash and debris, causing massive, fast-moving volcanic mud flows called lahars. On the southern and eastern flanks, flows rush down Muddy River, Pine Creek, and Smith Creek. Bridges are swept away, and Swift Reservoir rises as millions of cubic yards of debris pour in. (9:00 a.m.) Parts of the towering mushroom-shaped ash cloud collapse back toward Earth. The falling debris mixes with magma, mud, and steam, generating new pyroclastic flows, surging down the flanks of Mount St. Helens at deadly speed.
The Forest Service had a spotter plane ready to go, and we were off the ground probably at 9:05 or something like that. I mean, it was really, really rapid, and got up to the point where we could really see the mountain well, I suppose between 9:20 and 9:25, something like that. By that time, the blast had been completed. Of course, we could never get around to the north side of the mountain, so I couldn't see what had happened there, but we were able to see the south side very well. The flank was scored by mud flows that had come down it. There was this terrific, very vigorous vertical eruption column that was the stem of the mushroom or the toadstool that then blossomed out at greater height. And we could see during the course of the morning small pyroclastic flows starting down at various places down the south flank, never getting very far. For most of the morning, we saw this tremendous, whenever we could get around toward the west side of the mountain, saw this tremendous ash cloud roiling out toward the northwest. And I can only assume that was coming off of the big pyroclastic flows that were going off in that direction that later built the pumice plain.
The column now towers more than 15 miles high. Thunderstorms erupt inside the ash cloud, unleashing lightning bolts that cross the darkness and strike down into the forest below, setting the wilderness ablaze. 9:45 a.m. The town of Yakima, Washington, 90 miles away, plunges into total darkness as ash rains down. Roads close, flights are grounded, power flickers out, and a total of 5 inches of ash covers the landscape. (11:45 a.m.) The eruption's fallout reaches Spokane in the northwest of the state and starts into Idaho. Ashfall reduces visibility to 0 in several towns. 1:00 p.m. On the northeast slope, even larger lahars form, thundering down both forks of the Toutle River. At Camp Baker, observers watch a 12-foot wall of water, mud, and shattered trees surge past.
Up in there was a chunk of a debris avalanche, a landslide I was calling it. That was pretty amazing because you have to, for it to get there, what it meant is the landslide came down off the volcano, across the plain, went right through where Truman's Lodge was, into the lake, and they must have ridden the floor of the lake bottom all the way and come up on the other side. And there it was, a big deposit of it up on that upper end of the lake, these huge hummocks of dacite and basalt and stuff that had come off the top of Mount St. Helens. Behind some of the hummocks, that is on the side away from the lake, there were gigantic log jams. And they were clearly water-laid, there were rocks in them, huge things, almost as high as the hummock. That's a record of that water having been thrown up there and rushing back with this huge flood into the lake again and making these gigantic log jams.
– 3:00 to 5:00 p.m. The column holds steady at over 15 miles high. Pyroclastic flows continue to roar down the mountain, reshaping valleys and filling Spirit Lake with debris. 5:30 p.m. After nearly 9 hours, the main eruptive phase ends. The mountain is transformed. A mile-wide crater yawns where the summit once stood, and its peak is 1,300 feet shorter. When the mountain fell silent, the cost of its fury began to emerge. 57 lives were lost that day. It could have been far worse. The eruption struck on a Sunday morning when logging crews were away from the forests. Had it come a day later, the toll would have been much higher.
Look at this. It doesn't even look like the same country. Even the valleys have changed. And nothing matches the map.
Where's Spirit Lake? Is that it over there? I can't believe I've camped up in this area. It doesn't look like any place I've ever been before.
Among the victims was Harry R. Truman, the 83-year-old caretaker of Spirit Lake Lodge.
Later, I wondered if Harry Truman had maybe painted himself into a corner by being so firmly saying, "I'm never going to leave." So even if he had at some time become convinced that it was too dangerous, because it didn't take an eruption to wipe out Harry, just a landslide failure of that expanding bulge would have taken him out, I think.
The lodge, ash, mud, and debris. His body was never found. Volcanologist David A. Johnston was also lost. Just 6 miles from the peak, he monitored the restless mountain from an observation post on Coldwater Ridge.
I ran over to the radio and tried to raise Dave Johnston and gave him a call, and I didn't hear from him, and I didn't hear the repeater answer me back. And our repeater was located up on Coldwater Peak, which was quite a ways north of Johnston Ridge and way up high, and so I suddenly realized, well, something really serious has happened. If Coldwater Peak has been blown away and the repeater is destroyed, then I figured that something awful had happened at Coldwater too as well. So I guess I had the realization right away that this was some kind of a tragedy. And on the one hand, it was this huge, exciting, and interesting magmatic eruption, and on the other hand, I was pretty certain that something terrible had happened to Dave.
Seconds after the eruption, the pyroclastic surge reached him. His body, too, was never recovered. Others, like photographer Robert Landsberg, left behind a different kind of legacy. As the ash cloud approached, he documented the eruption until the last possible moment. He placed his camera in his backpack, lay across it to shield the film, and faced the end. Weeks later, rescuers recovered both his body and the photographs, images that gave scientists priceless records of the eruption's progression. In the days that followed, the devastation drew the eyes of the world. President Jimmy Carter, after surveying the blast zone, remarked, "Someone said this area looked like a moonscape, but the moon looks more like a golf course compared to what's up there." The eruption's effects stretched far beyond the mountain. Ashfall blanketed towns and farmland, causing nearly $100 million in agricultural losses across eastern Washington, hundreds of millions in today's value. Roads, airports, and rivers were choked with ash and mud, and entire communities grappled with weeks of disruption. The eruption had lasted only minutes, but its human cost, its destruction, and its lessons would endure for generations.
Over the next few days, as time permitted, we would revisit some of the old reflector stations, and they were all damaged beyond repair. But we tried to recover a couple of them and got approximate changes over the eruption.
There were people who were out measuring deformation and the real-time situation at the volcano, so to try to discern what the volcano was going to do next. Trying to recognize patterns at the volcano.
We put out new stations, and we quickly started to remonitor the volcano again, because we had no idea what was going to happen down the road, and we thought it likely that there would be more eruptions during the summer, and indeed that took place.
May 25th, 1980, 2:30 a.m. A sudden surge of earthquake activity precedes a new eruption. Ash shoots 9 miles into the sky amid a driving rainstorm. Erratic winds carry ash to the south and west, lightly dusting western Washington and Oregon. Pyroclastic flows race through the northern breach, covering the debris, lahars, and flows left by the May 18th eruption. June 12th, 7:05 p.m. A plume of ash rises 2.5 miles above the volcano, marking renewed unrest. 9:09 p.m. A more powerful blast sends ash 10 miles skyward, reaching areas previously spared. A dacite dome begins forming on the crater floor, growing 200 feet tall and 1,200 feet wide within a week. July 22nd. After weeks of relative quiet, the summit area shows expansion. Earthquakes intensify, and gas emissions rise. 5:14 p.m. The first explosion sends ash 10 miles into the sky.
And so we were out in the field on July 22nd in a helicopter, and we were down looking at some mud on the North Fork Toutle, and we were out of radio contact. And so when we got it back in the helicopter, took off, flew back to the volcano and came up from underneath the clouds, and here was this 20,000-foot ash column rising up, and the radio going, it's still at 30,000 feet and climbing. And where we were in the helicopter, we were so close, you couldn't see up to the top of the column of ash.
6:25 p.m. A faster blast pushes the ash column even higher in just 7.5 minutes.
After about 2 hours of circling over this and not seeing anything, suddenly this immense black eruption cloud came pouring up out of the white layer that the cloud tops. And I couldn't believe my eyes. I mean, I thought, this is the most incredible thing I've ever seen in my life.
7:01 p.m. A final 2-hour eruption removes the June dome, leaving eastern Washington lightly coated with ash.
The people in Vancouver were telling us to get off the ground because they didn't know what the volcano was going to do. And we were right next to an ash flow, so if another ash flow coming down would be right where we were.
August 7th, 4:26 p.m. An ash cloud rises 8 miles above the crater, accompanied by small pyroclastic flows from the northern breach. 10:32 p.m. A second large blast sends ash high into the air, moving north. A new dacite dome begins forming within days.
We've noticed that there were cracks developing on the crater floor that radiated out from the dome, more or less like spokes radiating out from the hub of a bicycle wheel. We didn't know if that cracking represented cooling of the hot crater fill that had been in place on May 18th, or if it represented swelling and extension of the crater floor. So we decided to start monitoring those cracks just to see what we could learn about them. What we found is that the cracks we were measuring were opening, and they seemed to be opening at an ever-increasing rate leading up to the last period of measurement before the dome growth.
October 16 through 18. A 3-day eruption obliterates the second dome, sends ash 10 miles into the sky, and creates small, red-hot pyroclastic flows. 30 minutes after the final blast, a third dome begins to grow. Within days, it reaches 900 feet wide and 130 feet tall, while a new glacier forms inside the crater.
After the dome had been enlarged in October and things had quieted down, we went back in there again. And through December, the cracks were widening again and at an ever-increasing rate, which led up to the dome growth at the end of December. Well, it doesn't take a rocket scientist to recognize that there were 2 periods that looked pretty much the same, so maybe this is predictive. So in January, we started doing the same thing. We also started climbing on the dome at about that same time, but we were continuing our measurements of the cracks, and the openings started to accelerate again. And so at some evening meeting we had over at the Forest Service building, I told Don Peterson, who was the scientist in charge here then, Don, I think that we're going to have another period of dome growth within X days from now, based on the crack. But we decided not to say anything publicly because we only had these 2 examples to go on. Lo and behold, we saw the same pattern before the next growth. So the next time around, leading up to the late March event, we again saw this pattern of increasing rate of opening, and so we then started going public and started making predictions with a time window within which we thought the eruption would occur on the basis of the rate of opening. But this worked remarkably well and was very useful to us and to the Forest Service in anticipating when the next period of crisis would be.
As 1980 drew to a close, the mountain entered a new phase. The violence of May had passed, replaced by the steady, methodical rise of lava within the crater. Instead of towering ash plumes or roaring blasts, Mount St. Helens now built itself slowly with each new outpouring, reshaping the raw, shattered landscape left behind. For scientists of the U.S. Geological Survey, the challenge was far from over. Every tremor, every wisp of gas, every fresh swell of rock raised the same question. Was this the calm rebuilding of a wounded peak, or the prelude to another catastrophic eruption? – 2004. September 23, 2:00 a.m. A swarm of small earthquakes rattles beneath Mount St. Helens, echoing the restless pulses that once heralded the 1980 eruption. September 26, 12:00 p.m. Steam vents burst through the crater floor, sending white plumes curling into the sky. The United States Geological Survey issues a notice of volcanic unrest, stating that a hazardous event was possible. September 27th through October 5th. Signs mount day by day. Steam blasts burst from the crater. The growing lava dome forces ice to crack and tumble, and harmonic tremors shake the ground. With each surge, officials raise the alert level, watching closely as the mountain stirs.
Today we deployed with a helicopter and a multi-sensor instrument package that was developed literally in the past week, or at least fabricated in the past week at the Cascades Volcano Observatory. This was in response to what we've been learning about the volcano over the past 2.5 to 3 weeks. The first thing we did was deploy ground deformation instruments out on the outer flanks of the volcano and learn that they weren't moving. Then last week we deployed 3 GPS instruments on the old part of the lava dome itself, and discovered that it's moving very little, if at all, at the same time that the feature on the south crater floor is moving by tens of meters. And so we wanted to get instruments directly on the part of the dome that's moving so dramatically. And so we very quickly put together a GPS sensor, a seismometer, a tilt meter, and a microphone. The microphone will record the sounds of explosions should they occur. And that's important. If they occur in the middle of the night or in bad weather, we'll have some indication that that's what's happened and integrate that into the rest of our data stream. We'd like to know, for example, is the deformation continuing? Is the rate increasing or decreasing? How does the rate correlate with seismic activity? When we're having more earthquakes, is the ground deforming more rapidly or less rapidly because it's easier for magma to move up the pipe and therefore producing fewer earthquakes? We don't know such fundamental things, and understanding those kinds of relationship is key to our trying to interpret the processes that are going on, understand where the volcano might be headed, and therefore mitigating any hazards associated with future activity.
October 6th. After reviewing fresh data and comparing it to past activity, USGS scientists conclude that a catastrophic eruption is unlikely. The alert level is lowered, signaling that the immediate danger has eased. For the next 4 years, the activity continues, steady, persistent, but without the violence of 1980. Dome after dome piles into the crater, building a jagged monument of fresh volcanic rock. July 2008. It is determined that the eruption that began in 2004 has ended, after 5 months of inactivity. By this time, the crater holds a massive new feature, a sprawling dome more than 1,500 feet high and nearly a mile long. During the 4-year-long eruption period, some wondered if these rumblings signaled the approach of another catastrophic blast. The earthquakes, the gas emissions, the relentless extrusion of lava, all echoed the mountain's deadly history. But this time, the eruption remained quiet, contained within the crater walls. Mount St. Helens spared the world a repeat of 1980. Yet the lesson was clear. This is not a mountain at rest. Even today, it remains an active volcano, its story unfinished. A reminder that beneath the Pacific Northwest's forests and rivers, forces of fire and stone are still at work. The eruption of Mount St. Helens on May 18, 1980 was more than a disaster. It was a turning point. In seconds, landscapes were erased. Lives were lost. And entire communities forever changed. For families, it became a scar that time cannot fully heal. For scientists, it was a lesson written in ash and fire, driving advances in monitoring, preparedness, and our understanding of how volcanoes behave.
Obviously, for volcanologists in the United States, the Mount St. Helens eruption was a spectacular learning opportunity.
We learned a lot about how you interact with civil defense, with the public, with the press, and that was transferred by the press to the world. And as a result, I think volcanology took a quantum leap in science as well as applicability to society's needs. And I think it was probably the most important eruption in the history of volcanology.
I think all of us were a little numbed by having lost Dave Johnston, and I knew 2 other people who were killed in the eruption as well. And so we were both more wary of the crater than we might otherwise have been. And also, speaking for myself, I was also motivated by those deaths to try to do better than I was doing before, to down the road try to save lives that to kind of make up for the loss. So I think we were both cautious and moved to do better as a result of what had happened on May 18th.
Out of destruction came renewal. Over the decades, forests, rivers, and wildlife have slowly reclaimed the blast zone, offering a living testament to nature's resilience. Mount St. Helens endures as both a warning and a teacher, a reminder of the raw power beneath our feet, and the balance that exists between vulnerability and renewal.